Chapter 4, Example 2. Your class was investigating the distribution of colors in bags of M&Ms and had the following results from a sample of 19 bags. Find the 5-number summary, IQR, mean, and standard deviation for the yellow M&Ms. So we're going to find those 5-number summaries and a couple other things. We need to make sure we can do these calculations. It's already in order for us, the yellow, so the minimum is 6, the maximum is 15. We have 19 bags, so 19 plus 1 divided by 2 equals 10. The 10th M&M is our median. And that comes out to be 8. So that 10th M&M is the middle, so I have 9 below 10, 9 above 10, so 9 plus 1 divided by 2 is 5. So the 5th M&M before the median and the 5th M&M below the median will be our Q1 and Q3. So Q1 will be 7, Q3 will be 10. IQR. The IQR is Q3 minus Q1, so I do 10 minus 7, which gives us 3. The mean, we're going to add all those values together and then divide by 19. Now I'm going to cheat a little bit when we put this out. There's 4 6s. So instead of doing 6 plus 6 plus 6, I'm going to do 4 times 6. There's 3 7s. So instead of 7 times 7 times 7, I'm going to do 3 times 7. And so on. So it will look a little weird when I put this up here. But we multiply all that out, divide by 19, and we get a mean of 8.68 M&Ms. Standard deviation. So I'm going to use that whole formula. And I'm going to kind of abbreviate this again when I do the square root. I can do 6 minus 8.68 squared. And then we're going to add that together 4 times, so I can do 4 times that quantity. I can do 3 times 7 minus 8.68 squared, and so on, just so it doesn't take up 3 pages of paper. So we're going to write all that out. We're going to do each one by hand, so we make sure we know how to do it. So 4 times 6 minus 8.68 squared, 3 times 7 minus 8.68 squared, and so on. Divide by 19 minus 1, which gives us 2.60. Compute side-by-side dot plots of the distribution of M&M colors and compare the distributions. So we went ahead and provided you with all of the 5-number summaries. And then we want to make sure we calculate the upper and lower fences before we do the box plots. So remember, our lower fence is Q1 minus 1.5 times the IQR. The upper fence is Q3 plus 1.5 times the IQR. So for red, I'm going to have 5 minus 1.5 times 4, which is negative 1, because clearly 9 minus 5 is 4. That's the IQR. The upper fence is 9 plus 1.5 times 4, which is 15. Now my maximum was 15, my minimum was 3, so I'm not going to have any outliers there. For yellow, we're going to do the same thing. 6 minus 1.5 times 3 equals 1.5. For the upper fence, 10 plus 1.5 times 3, which is 14.5. Now in this case, my maximum is 15. So yellow M&M seems to have an outlier 15. They have 1 point above the upper fence. For blue, same thing. We'll do those calculations, lower fence and upper fence. So my lower fence is 2. My upper fence is 26. In that case, again, no outliers. Brown, lower fence and upper fence. I have a lower fence of negative 1, upper fence of 15. No outliers. For green, doing the same thing. Again, it's important you know how to do these calculations. That's why I'm doing it 6 times here. Make sure you understand how to find an upper and lower fence, and you always remember to do that for box plots. So my lower fence is 1, my upper fence is 25. Again, no outliers. For orange, last set of calculations here. Lower fence is 1, upper fence is 10. So we'll write that down at the bottom. Lower fence 1, upper fence 10. This time I have an high outlier again. At least 1. It could be more than 1. Lower fence 1, upper fence 10. So now I have all the information I need for side-by-side box plots. I went ahead and used technology to graph these. You need to make sure you know how to do it by hand as well. So in this case, we had 2 colors, yellow and orange that both had a maximum value above the upper fence, so they had an outlier. It turns out there's only one when we looked at the data. Now, if there had been two, for example, in orange, if there had been a group that had 11 M&Ms and 12, I would have 2 dots up there, but that's not the case this time. Now we want to compare the distributions, which means I'm going to cuss. Blue M&Ms appear to be the most common color, with a median of 15 M&Ms. This median is at or above the maximum number of M&Ms for every color other than green. Orange is the least common color of M&Ms, with a median that is below or at the first quartile of every other color. Blue M&Ms have the largest variation, with a range of 17, and brown has the smallest range of 7. Both orange and yellow had the smallest IQRs of 3. The distribution of blue and brown M&Ms are symmetric, while that of green M&Ms is skewed left. Both red and orange M&Ms appear to be skewed to the right. The distributions of both yellow and orange M&Ms show high outliers